So you're going to be working a lot with lines in Miss Avila's class. Something that you need to know as a basic tool is the coordinate point, and that is a number identified at a specific point. So for example, the coordinate point of A is -3, the coordinate of E is 5. How do we find the measure, let's say, from a line between A and B? All you have to do is, number 1, count the number of marks, and then 2, find the difference. So let's count. We see there's 1, 2 marks. So that means the difference between A and B is 2. So that would be our length. We just did a segment measure. So in our example 1, determine the measure of line BF and FA. Use the coordinate point below. So what you should do, take a minute to solve that, and then when you're ready, check your answer. So the answer is, if we count from B to F, we see that there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 marks. Or we could just find the absolute value between 7 minus -1, which is 8. And FA between 7 and -3. So if we did 7 minus -3, absolute value, that means the distance between FA is 10. Try on your own, using the coordinate plot above, determine the measure of AD. So the answer to this one you should have gotten. AD, we would do -3 minus 3. So that is a total of 1, 2, 3, 4, 5, 6 marks. So the line AD, the length is 6. Another important rule to know is segment addition. So first, try out these problems. Are each of the following true? So does AB plus BC equal AC? Does AC plus BD equal AD? Does AB plus CD equal AD? And does BC plus CD equal BD? So for number A, yes, AB plus BC equals AC, that total line. And also for B, AC plus BC, does that equal AD? So that is no, because AC is total of 8 and BD is a total of 6, but A to D is 5 plus 3 plus 3, which is 12. So the math does not add up. So B is not true. For C, you get AB plus CD, AB plus CD. Does that equal AD? No, because it skips the line in between, BC. And finally this one, line BC plus CD, does that equal BD? Yes, because it connects all the dots between the line. So we would add 3 plus 3, which equals 6 for number D. So here's the official property. AB for segment addition. AB plus BC equals AC if and only if, first, points A, B, and C are collinear, which means A, B, and C are on the same line. And the measure of AB plus the measure of BC equals measure of AC. So AB plus BC equals AC. So here's some practice. Find the following segments using our knowledge of the addition segment property. So if we know that AE is equal to 21 and AG equals GF equals FE, then what does AG, AF equal? Take a minute to solve that. Alright, so if AG plus GF plus FE is AE equals AE, then we can just set AE equal to 21 equals 3x. So 3 divided by 21 is 7, and that means AG and AF are 7. AG is 7. AF is 14 because you do 7 plus 7. GF is 7. And then BC is, since we know AC is 15 and AB is 8, so then we would just subtract 15 from 8, which means BC is 7. So why don't you try to find x on your own? So you have AE equals 20, AG equals x plus 2, and then GE equals x plus 6. So find x. So to find x, you would set up AE equals 20, so 20 equals AG x plus 6 plus x plus 2. So then if you combine the like terms, you get 2x plus 8, and then you subtract 8 from 20, which is 12, so x equals 12. Okay, so the next formula that you need to know is the distance formula. So remember the coordinate plane. You work with coordinate points x and y here on the x-axis and the y-axis. There are 4 quadrants. This is number 1, this is number 2, this is number 3, and this is number 4. When we're looking to find the distance, or the length between 2 points in a coordinate plane, we use the distance formula. And this is the distance formula. It's the square root of x2 minus x1 squared plus y2 minus 1 squared. So try this, pause the video, and try this example on your own. Example 1. If A coordinate is 1, 1, and B, the coordinate is 4, 5. What is the distance formula for line AB? So, what you do is you plug in your x2 and x1. So here x2 is 4, x1 is 1. So then you get 4 minus 1 is 3 in this parentheses. The next one is 5 minus 1 is 4. So we will get 4 in this parentheses. So since there's 3, 3 squared is 9. 9 plus 4 squared is 16, is 25. the square root of 9 plus 16, which is 25, is 5. So that means line AB has a distance of 5. So a term that you'll hear often in geometry is congruent segments. So congruent segments have the same shape, same length. The symbol for congruent is the equal sign and the similar sign put together. So, are the two segments congruent? The measure of AE is 20 and the measure of AG is 20. So yes, we can see that they are segments that have the same length, therefore they are congruent. So yes, AE is congruent to AG. So we won't try examples for congruent because we want to get to the last part, which is the midpoint. Right here. The midpoint of a line is a point that separates the segment into two segments of equal measure or two congruent segments. So you want to use hatch marks to show the segments are congruent. And the hatch marks I'm talking about are these little lines right here. They mean AM and MB are congruent, or remember, like we said earlier, they have the same length. So if M is the midpoint of line AB, and if M is on AB, and then AM is equal to MB, then AM is congruent to MB. The bisector of a line. So this is a line, ray, or segment that separates the segment into two segments of equal measure, two congruent segments. So here we see EF is a bisector of CD. That means CM is congruent or equal to MD. So see, when a line cuts it in half, the hatch marks tell us that CM is worth the same amount as MD.